Is this working? Yeah. Okay. So the idea actually was to raise the awareness to tautomers to the larger audience, not only to those who already know about tautomers and their issues. And as Greg alluded to, thinking and talking about tautomers can quickly turn into a giant rabbit hole that I actually also don't intend to get into. But I can say for myself that I really still underestimated the influence that tautomers have on our research, actually. And so for me, this all started when I realized that the canonical tautomer of some of my structures didn't look at all like I expect them to look. And I noticed this in this example of the aminopyridine, which was canonicalized into this exocyclic imine form, which really didn't go along with my expectations. And then I started thinking about tautomers more in detail, and yeah, also definitely want to mention Roger's talk, of course, from last year's UGM again, definitely worth a look in that context. But when you really think about tautomers and what they all influence, it's pretty much everything. So Inchi keys depend on the tautomeric form, smiles, of course. This is important for identity determination of structures. Fingerprints as well are influenced by the tautomer, which, as we've seen today, are used for similarity determination, substructure matching, and also model training. And a number of scores and descriptors, which also are used in model training a lot, depend on the tautomeric form. The QED, so the quantitative estimation of drug likeness. For example, the natural product likeness score, which is also implemented in the RD kit, is influenced by it. The log P and pKa, and this is maybe most important. So, for example, if you're training a model and that is supposed to model a physiological state or something depending on physiology, like absorption, for example. So log P and pKa also depend on the tautomeric form of a structure, and many more. So in the RD kit, the goals of the canonical tautomer generation are, of course, mainly that of consistency, and that is of course, a completely valid goal, but the consistent tautomer that is generated is not, or is sometimes not, that which looks intuitively correct, and that is the point of discussion. So, I mean, when you're talking about this correctness, and therefore I put it in quotes, it quickly becomes almost philosophical, I would say. The correctness depends, of course, on different factors like the solvent and also the pH in which the structure is to be considered. But my expectation or my hope would be that a certain level of, let's call it, intuitive correctness should be provided by the canonical tautomer generation, if that is possible. And we had last year a nice talk about a structure score, which we then in the end dubbed "Will I be getting yelled at?" By my superiors. And this, I think, is a similar situation for the tautomer. It should, for let's say 80 to 90%, be intuitively correct, the structure that is generated. So, yeah, to sum this quickly up and maybe open it to discussion, but again, I really do not want to go into this rabbit hole. Maybe we can rather discuss how everybody is doing it. But at least for me, tautomers and also the canonical tautomers are much more important to my research as I initially thought. I can really say that about me. Although we have talked about tautomers multiple times here in the ADICAT UGM. Therefore, it is really important to always standardize your structures, especially when they come from different sources. And yeah, also another thing, there are two modules in the ADICAT to calculate a canonical tautomer. The one is, as of my understanding, the older one is implemented in Python, the first one listed here. And there's a new implementation in C++ now. And the catch is that these two implementations give different results, which is the other discussion point linked above about. So yeah, that's my 2 cents on that topic. And we can discuss now if people want to, are ready. But what I really wanted to do is raise awareness again of on how important tautomers really are. Yeah.
Thanks. So from my perspective, I agree with a lot of what Axel said. There's some stuff I disagree with, but we can talk about that. They're obviously really important, and they change, as you said, they change properties, descriptors, fingerprints, etc. They change dramatically sometimes based upon which tautomer you use. And I think that's why it's sad that everybody left already and didn't hear this part, because I think most people in our community, particularly people earlier in their careers, are just totally unaware of this. No. So that's unfortunate. They had an opportunity to hear it and didn't. Maybe we can try and catch them later. To a couple of points here. Just the trivial one, there are two canonical tautomer codes. The first one is the old MolVS implementation that will go away in the next version. The Python-based one is totally gone, will be gone in the next version. We've only left it there so long because it takes us a long time to remove things.
Okay.
The new tautomer canonicalizer, the stuff in RDMol standardized, is what people should be using. And it should be a little bit better in terms of, well, better. So let's talk about better. The goal,
I can confirm that in some, so I haven't done a thorough study, but I looked at a few examples, and the structures of the new implementation were more intuitively what I expected, to put it that way.
So just let me quickly finish, and I'll come to you, Thomas. The goal, as Axel said already, the goal of the tautomer canonicalizer is just to make it, to answer the question, if I have two tautomers of the same molecule, I should get the same canonical tautomer. Okay, it's the same thing that Inchi does. It generates, you give it, no matter what tautomer you give it, you get the same tautomer out. What the tautomer that Inchi generates is frequently really ugly. So if you ever actually look at the structure that Inchi encodes, the tautomers are normally terrible because they're not designed to look nice. They're designed to be canonical. The ArtiKit canonical tautomer is also designed to be canonical. It's not designed to look nice. However, we put a little bit of effort in to trying to make it so that hopefully a large fraction, not everything, but hopefully a large fraction, does not make a chemist's eyes burn too badly.
Yeah, exactly.
So that does not mean you will not be able to go through a set of structures and find things that you look at and you go, oh my God, this is awful. But again, the purpose is not to show you the most stable tautomer in solution at any particular solvent for any particular pH. It's just to show you a canonical tautomer so that if I give you the same molecule in different tautomers, you recognize that they're the same. That's the overall goal, which Axel said already. I just want to be very clear about that particular point. So anytime you see a discussion, which happens fortunately not as often now as it used to, where somebody says, I got the wrong canonical tautomer because this is what it should be in solution, they have not understood the problem, right? So the wrong canonical tautomer, the bug report is, I have two tautomers of the same molecule, or two tautomers of what should be the same molecule, and I got different canonical tautomers for them. Right? That would be a bug report. I don't like the tautomer I got is not a bug report. And that's a disagreement about design, to be clear. From a scientific perspective, actually doing the thing of predicting what the actual stable tautomer is in any particular solution at any particular pH at any particular temperature is an unsolved scientific problem that requires quantum mechanics. So we're not going to solve that at the cheminformatics level. We're not even going to try. If you want to do calculations and build a deep learning model to do it, it's fine. Maybe people will find it useful. The RDKit generates canonical tautomers, and it'll enumerate tautomers for you. So you can have it give you all of the tautomers using the rules that it uses for tautomers. And that's what's there. Okay. Do you still? Okay. Yeah.
So also we're not aiming for the correct tautomer solution or in air, but is there like a tautomer everyone agrees on, which is the nicest looking one? So we can adapt maybe the scoring for the tautomer so that at least look nicer. Or is it also like something no one agrees on what should be depicted?
I'm a huge fan of Tom Sander. In part of Data Warrior, there's a database called Tautabase of 1,800 experimentally observed tautomers. And they completely agree with Axel on the two molecules he showed. The chemist would be surprised to see this, and lo and behold, the experimental evidence agrees with what Axel expects to see, which was slightly different. It's an interesting. I'm as I explained last year, completely conflicted and with Greg on this. That it is the role of a canonicalizer is to show that two things are the same. But within that parameter, the more you can make it close to the physiological or the one that's seen in water, the better. And so that benchmark of 1,800, because yes, is a benchmark you don't fail on, because if you spot two things the same, that's fine. But if there are refinements and tweaks that can be made to RDKit to better align with the more commonly one, ultimately ends up in a rat's nest. I mean, the whole point of my talk last year was you end up in quantum calculations and Huckel theory to try and get the ideal one. But it is interesting that how big the differences are at the moment. And NHS is far worse, right? So it'll do A minus.
Please correct me. I think the example you said it was the old code.
Yeah, that's correct.
So the new code does not do that.
So there's this newer blog post where I realized that there are two different tautomer canonicalizers for the tautomers. And here I actually compare the two versions. So the top one is the old one from MolVS, and the bottom one is from the new implementation. And yeah, this is one of the examples where I think that the new implementation looks nice.
So my take on that, I'm happy to modify the rules if we can find examples where the RDKit is doing something that it's obviously we can fix it with the scoring function. The thing we have to be a little bit careful about is people do actually use these, and I try to be a little bit careful about breaking things from one release to the next. We can definitely do it. It would be one of those things that come out at the major release thing. So we could only do it every 6 months, and it needs a lot of communication, but we do that all the time. So I'm happy to change the rules, but not for edge cases, right? So for things where it's really obvious, the data set from Thomas Saunders is a good one for this. So if people see things that they really don't like, that it should be better, we can talk about changing the rules. But again, it's not something we're going to put a huge amount of time into, because this to me is a nice to have, not a must.
It is also that the RDKit is not
No.
but no.
I'll come back. Yeah, no. Well, did you want to comment to that specific point? Okay.
No toolkit that provides perfect tautomers in all cases.
No, they may be perfectly canonical, but you can't like.
So, sorry. support. Yeah.
The other subtle point to avoid getting caught up on was a talk I gave far too long ago. You're 100% right. Values like log p shift greatly between one tautomer and another. And I gave a presentation on how, well, actually, if you find the one that's closest to the experimental log p, that must be the correct physiological tautomer and the one that's producing a large error. And then it analyzed a number of different algorithms. And so C log p at the time was based on fragments and fragment-based discovery. It had, let's say, 50 examples of tetrazoles. 49 of them had been drawn correctly, and of course gave you a scatter plot and an approximate log p. The one that was drawn badly in the data set was picked up by machine learning, added as a fragment, and got it spot on because it was overfit and over parameterized based on the sampling problem. And so it's not as simple as better is better.
Just perhaps the other perspective, because I have to develop the INCHI any further. First, we are lucky because we do not need a nice representation, because nobody really looks into the INCHI. No, but the next step we are looking into is, already for a while, we are looking into 119 transformation rules to make it even more unique. Having in mind, for example, that sometimes you pay double or 3 times the price for the same compound if it's just drawn as another tautomer. Yeah, it's really relevant if you have to buy compounds, for example. But now we have all of those rules, and meanwhile we have to really test them because we found out that suddenly the peptides will fall under those tautomers as well. And now it's getting critical because you lose stereochemistry, for example. And that will be quite an ongoing process because somebody calculated already that about 30 to 40% of all the PubChem compounds are just falling under those categories. It will be a very thin line we have to develop, and it will take more time. We are just working on a prototype first to see where we come to.
But for people who haven't spent a lot of time on this, there was an entire issue. It was JCAMD, right? There was an entire issue of Journal of Computer-Aided Molecular Design 10, 15 years ago, focused on tautomers. If you do computational chemistry, you really should read every paper in that and commit as much of it as you can to memory, because it's enormously complicated and it's really, really important. So from a scientific perspective, that issue is just a fantastic thing to look at. Roger has a really nice paper in there as well. So you thought you understood tautomers paper. Yeah. I thought I did, and then I read Roger's paper and realized I didn't. Hopefully I'm a little bit better now. The other point I want to make is there's this thing, computational people occasionally get worked up about the thing that is most stable in solution. Which is an equilibrium property, and it's a particular solvent at a particular temperature and a particular pH. And I think that's important to remember for bioactivity or any experimental property. Bioactivity in particular, that's a non-equilibrium phenomenon. And the protein is perfectly capable of filtering out a minority tautomer. I mean, there are many examples you can find in the PDB of the same compound or closely related compounds in different tautomers crystallized in proteins. In all cases, they came out of solution. So solving the problem of I have the right tautomer in solution is not actually going to solve all of the scientific problems, because if you want to do docking or MD or whatever, you need to be docking with the right tautomer. So you probably need to enumerate to do this. So the problem is not solved by just having the right tautomer in solution. You really need to look at all of them. I have a bunch of slides on this. That thing from JCAMD has a bunch of information. Take a look at it and think about it. Are there other? Yeah, Patrick, and then I'll come to you.
As a quick note, so you described a few properties that are tautomer dependent. And the one thing I didn't see there yet, and I don't know how much this is in the awareness. So the RDKit uses the smarts hierarchy, right? For torsion assignment. Yeah, these are our smarts, or yeah, okay. So because we know that our smarts are tautomer dependent, and so you will get different conformers depending on the tautomer you put in. Yeah, which is correct, but definitely something you should be aware of if you're, yeah. Yes. Yeah. So just to put beside the 2D properties and the just atomic graph properties, there are 3D things that are very relevant here.
I wanted to say that, like, in my experience, the new implementation of the canonicalizer actually works great and like solves the problems of the MOVS implementation. And on the other hand, I was basically just wondering if it's simple enough to explain what rules you're using for choosing what the canonical tautomer is, if we can basically discuss on whether these are sensible to change or something like that.
No, I can't. And that's just because I don't remember. We have to look at the code. So the rules are enumerated. There's a set of rules for doing the enumeration, which are based upon a paper from the NCI group. From years ago, for rules for doing enumeration. And we've extended those a little bit, but it's basically enumeration based on those rules. And then we pick the canonical tautomer by a set of very simple scoring rules. They're basically the ones that are in MolVS, but we've added a few corrections and cleanups. I can't describe them all right now because, again, I just don't remember. But I could probably do a blog post on that to try and reduce those into words with what's in there, because it's code at the moment. No? Yeah, shout, I'll repeat it. No, so you can't shout.
Perhaps we could use an AI model to solve this problem. I was going to ask Axel, you mentioned that you tested several toolkits and they all had some problems. Do you have a test set?
No, I just tested the corner cases that I detected gave to me weird results in RDKit, and I put them into other toolkits to see how they perform there. So it's not a huge test set. It was very personal.
Well, even so,
just a few molecules.
Even so,
yeah, okay,
would be useful.
Yeah.
Sorry.
So disclaimer, I don't want to start a fight with anyone about the tautomer question because it's really not in my courts. But one thing that I would like to mention is that even though they are definitely formally correct, what I found is that sometimes the tautomers generated by the canonical tautomer enumerator are a bit too far from the starting molecule. So the recursive application of the rules sometimes brings certain like double bonds to migrate very far from their original position. So in that respect, even though I'm not challenging the canonicalization thing, because they're definitely canonical, they're reproducible, I think it would be good to have something that produces tautomer, I wouldn't say of better quality, but something that make them less different from the input tautomer when the input tautomer is perfectly sensible one. And in that respect, I think that it would be nice to get the Syngenta paper implementation into the RDKit. I know that Richard Lewis had done significant work to get the reaction smart ported to RDKit, and I really want to find some time to dig that data out of his hard disk and bring it to RDKit, because I think that having an additional tautomer canonicalizer based on business rules would be good, even just to compare what comes out of both.
I just wanted to reiterate, so last time when I was doing tautomer benchmark for an experimental data, like all the different generators out there could not, based on input smiles, could not find the ones in experiments. So I would always say like the role of RDKit would be to generate as many possible tautomers as possible, and then it's my problem to sort through them to find which one is right. I'm afraid of implementing rules that will remove tautomers from it, will remove them from quantum chemistry calculations in my world, which I would be, against. I don't trust chemical intuition. I trust quantum chemistry.
I think just as an aside, one of the points that should be made is the reason I stated to have a canonical tautomer was so that you could have two tautomers of the same molecule and say that in fact these are the same thing, at least at a tautomeric level. And that the reason being able to answer that question is the only reason the canonical tautomer thing is in the RDKit at all. Because Susan may remember when Susan did the actual port of MolVS to the RDKit back in the day. And she may remember when she was doing this, I said, I don't want to do the canonical tautomer thing because I know it's just going to lead to arguments. And then eventually you changed our mind and we did it and now it's there and we can keep improving it. But I think what you as members of the community and users should know, if the question you're interested in asking is, are these two molecules tautomers of each other? A much better way to do that is to calculate the tautomer hash that's in the mole hash module and just see if the two molecules give you the same hash. That is a much better way of asking are these two molecules tautomers of each other? Rather than generating canonical tautomers, which is a fairly expensive operation. So if you just want to ask the question, are these two molecules tautomers of each other? The mole hash is a much, much better way of doing it. That was my little aside. Are there other tautomer things? So I'm not going to run all around. I'll give it to you, then you can hand it to Ed and you can go that way.
Okay. Thanks, Greg. So I think we are here running in a bit of an area of uncertainty because it depends a lot on the context if two structures are actually tautomers or not. In a given protein, they may be tautomers, or in a different environment, they may not be tautomers. And I think it's kind of very, almost impossible to have kind of a fixed rule here. What's a tautomer? What's not a tautomer? But we're really running into some area of uncertainty and fuzziness here. It's more a comment rather than a question.
Maybe go get up later.
So I've got two things. First of all, we don't to add to your list of things that are very dependent on tautomers. To me, it's very obvious, but just for those people who haven't run into it, if you ever start generating matched molecular pairs, it's so obvious until it just kicks you in the head. So that's one just to be aware of that we got into very early. One of the things we then discovered, which is an even worse gotcha, is the corner cases where you have two tautomeric groups that are actually conjugated to each other. And you can end up with basically your rules fighting each other. That's quite a bad corner case. Now, it's a corner case, so most people don't have to worry about it. And most of the time, you just want to filter it out of your system. But as you move towards dealing with registration systems, whole company files, the problem is that often medicinal chemists, agrochemists have an interest in molecules where you have these extended conjugated systems. And so therefore, despite the fact they are, you would expect them to be very rare, they're enriched in the kinds of things that bluntly the bastards want to make, so I don't know, it's an added level of problem. We have some solutions, but you end up getting down to if you spot something like this, you end up making another rule, but then it's just a version of the qualification problem that your rules never end. Sorry.
Yeah, so there is a question from my side. When actually showed the presentation, when I looked at the structure and I use the INCHI key for the lookup, And why Inchi because it handles the tautomerism, but to some degree, and I actually used two experimental options which I found in the documentation. One is a kit, which handles ketonol tautomerism, and another one is 1,5-T, something like that, which handles 1,5 tautomerism. Because without it, I actually ended up with the same structures having different Inchi keys, and that's not what I wanted. And so the questions, do these tautomerism generated, tautomeric smiles generated by RDKit also kind of have generate the same smile and behave the same as NGK with options or without? Yeah, so because the behavior of NGK is a bit different. Yeah.
So the RDKit enumeration rules are not the same ones that Inchi uses. They're different. The default set of rules, you just have to look at the molecules that you have and look to see if they're covered. They're broader than the Inchi rules, I think, but it's worth checking. And they are configurable, so you can always add rules if you want. So there's a configuration option where you give it the list of enumeration rules, so you can actually have it if there's something missing, you can add it yourself and then have your own version of the enumeration. The canonicalization bit then just goes through all of the enumerated structures and picks the one that scores best. So that will automatically lead to the canonical one being picked potentially from that set that includes your new tautomers. Anything else? Okay, that didn't get nearly as heated as I was afraid it might. My blood pressure. Oh, you want to ruin it, Ash?
I think the question which Axel asked went unanswered. How is everyone doing it? I'm also curious, like how are people downstreaming their compounds from millions of compounds to, let's say, hundreds of them? So is tautomer canonicalization, like you just do it by like the function provided by RDKit, or do you have some other tool you use? Okay. Nodding heads is the answer. I see. Thanks.
Does anybody want to specifically comment on that? So I can tell you what Novartis did because I was involved in that system, and I've talked about it publicly before. Novartis registers the tautomer that the chemists draw, and if the chemist draws a tautomer or molecule which is a tautomer of a registered molecule, they will be offered the option and said, "This is already there. Do you want to register this anyway?" And it allows them to register it. And that's very important because in a registration system, you need to capture what actually is being measured. And your stupid tautomer enumeration rules are guaranteed to not cover everything. So you always have to let the chemist register what they think they have. They're maybe not going to be right, but that when you get into an argument with them, they will be right more often than you are. So everybody takes different approaches to this, but that was the rule we used, is whatever the chemists draw, we register. And then we had ways later to, if you wanted to, roll the data up at the tautomer level. So show me all of the results for this molecule. I don't care about tautomers. I'll talk about a little bit about this tomorrow when I talk about the lightweight registration system. All right, thank you all. Hopefully this was useful for the people who were just sitting listening. Hopefully it was useful for the people who were participating. Axel, thank you for raising it.